Hello everyone, and welcome. When you hear about an explosion involving a Tesla, it can sound pretty dramatic, sparking a lot of questions and sometimes misconceptions. Today, we're diving deep into Tesla explosions, or more accurately, thermal events, to explain exactly what happens, why it happens, and what it means for electric vehicle safety. We'll break down the science, clarify the common myths, and give you a clearer picture of battery technology. Get ready to understand the truth behind these rare but impactful incidents. 1. Understanding the lithium-ion battery. At the heart of every Tesla, and indeed almost every modern electric vehicle, is a lithium-ion battery pack. Imagine this pack as a large array of thousands of individual battery cells, similar in concept to the batteries in your smartphone, but on a much grander scale. Each cell contains an anode, a cathode, and a liquid electrolyte, designed to store and release energy efficiently. Picture these cells working together to power the car for hundreds of miles. While incredibly powerful and efficient, these batteries store a lot of energy in a small space. The challenge arises when this energy is released uncontrollably. Understanding the basic structure of these batteries is key to understanding what happens during an incident. 2. The thermal runaway phenomenon. When we talk about a Tesla explosion, what's actually happening is a process called thermal runaway. Imagine one battery cell overheating for some reason, perhaps due to damage from a severe impact, a manufacturing defect, or an extreme external heat source. This overheating causes a chemical reaction inside that cell, which generates even more heat. Picture this intense heat then spreading to adjacent cells. This creates a chain reaction. One cell heats up and vents hot gases, which then cause its neighbors to overheat and vent, and so on. This rapid escalation of heat and pressure within the battery pack leads to the venting of flammable gases and sometimes fire. Think of it less as a traditional explosion with a huge bang and shrapnel, and more as a rapid, intense fire that can expand quickly and dramatically release energy, sometimes with forceful bursts due to gas accumulation. 3. Causes of thermal runaway. While the visual might be startling, thermal runaway in Teslas and other EVs is extremely rare. When it does occur, it's typically due to a few primary causes. Severe impact damage. The most common cause is a high-speed, severe crash that physically deforms or punctures the battery pack. Imagine the forces involved in a major collision compromising the integrity of the battery cells. Manufacturing defects. Although rare due to rigorous quality control, a tiny flaw in a single cell could potentially lead to internal short-circuiting and overheating over time. Extreme external heat. In very rare cases, intense external fires from other sources could heat the battery pack sufficiently to trigger thermal runaway. Charging issues. While Tesla's charging systems are highly sophisticated and monitored, extreme overcharging or specific defects in charging equipment could theoretically lead to issues, though this is heavily safeguarded against. It's important to note that Tesla vehicles, like all EVs, have sophisticated battery management systems, BMS, designed to monitor cell temperature, voltage, and current to prevent thermal runaway. They also have physical safeguards like cooling systems and fire suppression materials within the pack. 4. Safety features and firefighting challenges. Tesla vehicles are designed with numerous safety features to mitigate fire risks and protect occupants. Imagine the strong, reinforced battery enclosure designed to resist impact. Picture the integrated cooling systems that keep the battery at optimal temperatures. In the event of an impact, the BMS can even detect damage and attempt to isolate affected sections of the battery. However, once a thermal runaway does begin, fighting an EV battery fire presents unique challenges for first responders. Think of the intense heat, the persistence of the fire due to the self-sustaining chemical reaction, and the potential for reignition even after the visible flames are out. Fire departments globally are continuously training and developing new protocols for safely handling EV fires, often involving vast amounts of water to cool the battery pack and stop the chain reaction. 5. Context and comparison. EVs versus gasoline cars. It's crucial to put these incidents into context. While a Tesla battery fire can look dramatic, electric vehicles are statistically less likely to catch fire than gasoline-powered cars. Imagine the everyday risk of a gasoline tank rupturing in a crash or highly flammable fuel lines igniting. Picture studies showing that EV fires occur at a lower rate per vehicle mile traveled compared to internal combustion engine (ICE) vehicles. When an EV fire does happen, it receives significant media attention due to its novelty and the visual intensity of battery fires. Think about the millions of gasoline car fires that occur globally each year that rarely make headlines. This comparison is vital for a balanced understanding of vehicle safety. Conclusion. So, when you hear about a Tesla explosion, remember it's primarily a thermal runaway event within a lithium-ion battery. While visually striking and challenging to extinguish, these incidents are rare and subject to continuous safety improvements. Tesla and the wider EV industry are constantly innovating to make batteries safer and more resilient. Understanding the science and putting it into perspective helps us appreciate the safety evolution in electric vehicle technology. Outro. What were your biggest takeaways from this explanation? Did anything surprise you? Share your thoughts and questions in the comments below. Don't forget to like this video, share it with anyone curious about EV safety, and subscribe to our channel for more insights into technology and its impact. Thanks for watching.